In this video, we're going to attempt to find all the asymptotes and sketch a graph for the h of x function. So I'm starting off with my graph. So I went to my graphing calculator. I typed this in. I used parentheses around the top. I used parentheses around the bottom. I did that because the top had different terms there with the plus and minus, and so did the denominator. For my graph, I'm going to choose zoom and 6, the standard window, and I get a graph in 3 sections. If you have an older calculator, it's going to attempt to draw the poles for you, and so your graph is going to be connecting, but these are the 3 pieces. We do not want those connections. So I'm going to try to sketch my graph. So my axis went from -10 to +10 in both the x and y direction. And I had these 3 pieces to my graph, so let me look at them again. Piece 1, piece 2, and piece 3, see if we can draw them. So piece 1, like this. And we have piece 2. Now we have piece 3. So it clearly appears that I have poles. I can see them. Depending on your graphing calculator, it drew them. So there's a pole or a line dividing the graph into different sections here and also here. So to find the poles, or also called the vertical asymptotes, you start by making the denominator equal to 0. So x squared minus 5x minus 14 equals 0. And in the others, I was able to solve this using a square root, but this time I can't do that. So I look to factor as my next method, and this is something that I can factor. So I would have x and x. Factors of -14 will be -7 and +2. And then each factor has to be set equal to 0. So x minus 7 equals 0, which gives me a pole at x equals 7. So that is this one right here, x equals 7. And same thing here. So x plus 2 equals 0. Subtract from both sides, x equals -2. And that is this pole over here. We're going to go back to the graph and look at those for a moment. So looking here at -2, I can clearly see that would make sense. That's where there would be a dividing line in this graph. And again at 7. So 1, 2, 3, 4, 5, 6, 7 right here, there is a dividing line through the graph. Now, it does look a little bit like the left and the right are going to approach the same line, even though I don't see that line here. We'll take a look at horizontal asymptote, also called a limiting value. Horizontal asymptotes are determined on the degree, so I look at the degree. They are equal, so I go back to my notes. When the degrees are equal, it has an asymptote at y equals ratio of leading coefficient. So pulling that back here, y equals leading coefficient is an unwritten 1 and an unwritten 1. So 1 over 1, which is 1. So that means, even though it hadn't happened yet in our window, these two will approach y equals 1. And that is my horizontal asymptote, and I had these 2 vertical asymptotes. Now, before we go further, I do want to show you one thing in your graphing calculator on your table. And that is that the horizontal and vertical asymptotes, the vertical ones, are going to show up in that table. So I'm going to set up my table to start at 0 and change by 1 and go look at those table of values. And right here at 7, which is where I had an asymptote, that is where I have that error message. And so that is where that pole shows up. If I go up here, my other one was at -2, and so again, I have where that pole shows up. Now I want to look at something else, and that's those horizontal ones. We said in the long run, both sides approach 1 as that limiting value. So I'm going to set up my window or set up my table rather, to start at 0 again. And this time I'm going to go up by tens, just so I go up and down really fast. So looking at that table, I can see that as I go up by tens, and this shows me up to 100, I'm getting really close to that limiting value of 1. If I go down by tens, I can see again, as I go down to negative 100, I'm getting really close to that limiting value of 1. And so whether you're approaching this from the left of the graph or the right of the graph, that limiting value, that 1, is the same on both sides. So on the left here in the negatives, it's a decimal. It's really close to 1. It's not quite there yet. On the right-hand side, it was just over 1 because it's coming in from a different angle. But both of those are approaching 1. And so that's how we can see those asymptotes show up in our table. The vertical ones show up as errors because they're domain restrictions. There's places that we cannot divide by 0. And then the limiting value shows up, and that is what the function is doing on the left and the right of the graph. It is going towards that limit.